All right, so if you did a test retake on Friday, that has already been graded and put in the grade book. Your quizzes from last week have already been graded, and I put them in the grade book this morning. So those should be reflecting for you now. The only other grade, well, I guess we have a couple more grades left for this 9 weeks. We're going to have the worksheet we're doing today, and then you're going to have the review and test that we're going to be doing on Wednesday. All right, so your next test is section 2. So we'll have 2 tests in the grade book. I think we have like 4 quizzes. I think 3-4 quizzes in the grade book. And then of course all of your homeworks and stuff are in there. So that will account for your first 9 weeks grade. If you are missing anything, I will not accept any late work past next Thursday. That is it. Or this Thursday. I lied. Sorry, got my weeks messed up. This Thursday is the last Thursday. Okay, that's when the 9 weeks is over. I can't put grades into the first 9 weeks exam, 9 weeks grade book when my grade book has moved on. Okay, it's physically impossible for me to do it. I cannot technically do it. So any late work you have, give it to me Thursday, by Thursday. All right. If you don't, if you show up after this long weekend on Tuesday with all of your missing assignments, guess what? Not taking it. I'm either going to give it back to you or throw them in the trash. Okay. Is Friday Thursday? Is that the same day? No, it is not. I'm not taking it. Thursday is the last day. You show up on my teacher work day trying to give me assignments, I'm throwing them in the trash. You missed the deadline. You should have done it the first time. All right, so one more lesson. We are going to do literal equations today. What do you think of when I say literal equations?
Like you have to add them and
Okay, well, what does like the word literal mean? Real, actual. It's what you say. Okay, these are all great things. We're going to be solving for letters now. Okay, so we'll have equations that we are going to rearrange. So we're going to rearrange formulas to solve for different pieces of the formula. Okay, so like in perimeter, when we get down there, perimeter, we use length and width, right? To find perimeter, same thing with area. We use the length, we use the width. So I'm going to be asking you to find the length or the width, okay, of the equation of it. So we're not going to get an actual number answer. We're going to be getting letters and stuff involved. All right, so stay with me. The notes are not very long, right? Our notes are very, very short today. And then we do have a good practice worksheet for our first half. And then second half, we'll start our test review. Okay? Yes, ma'am. Don't cross it out because we might do it later. We're just not doing it this 9 weeks. We might come back to it. Okay? So any distractions that are out, let's go ahead and put those away. And I shouldn't have to say that when my notes are starting. But I have, so let's respect and put it away. All right. So if I solved for each equation for x, for the first one, I have 2x, I covered it up, 2x plus 4 equals 12. What would I do to get x by itself? Yes, ma'am. Minus 4, okay, from both sides. That gives me 2x is equal to 8. All right, then what? Divide both sides by 2. So we get x is equal to 4. Beautiful. All right, my other one, 2x plus y equals z. Well, it still wants me to get this x by itself. Okay, so what am I going to do first this time? We're going to subtract still, but before it was a 4, right? Now it's a y. So we're just going to subtract y from both sides. So I have 2x equals, well, z and y are different things. So I'm just going to say z minus y. All right, now what should we do? We're still dividing by 2. But this time there's not numbers to divide by 2. We have letters to divide by 2. So we're going to keep it z minus y over 2. Or if you want to, you can separate them. Z over 2, minus y over 2. Technically, that's the same thing. I don't care which way you write it. All right, did we use different properties when we solved those two different equations? No, we used the exact same properties, right? What was the difference between the two? Yeah, one had numbers, one had letters. The second one was a literal equation, okay? So when there's letters that we are moving around and solving, okay, they're going to stay in my equation, okay? They'll stay in my answer. Okay, so all the letters will still be there. We're just rearranging, we're just moving them around using our opposite operations. All right, consider the formula for the perimeter of a rectangle is 2L plus 2W. It makes sense. We're adding up all of our sides. We have 2 lengths and we have 2 widths when it comes to a rectangle. Okay. Sometimes you might have all the information and I want you, to solve for just the length of that equation. Okay. Oh, go back. Okay. So if I ask you to solve for just the length using your perimeter, give myself some more space here. So we have P equals 2L plus 2. Well, that is an ugly 2. There we go, 2W. So we want to get that L by itself. Okay. Minus 2. What's the loose piece technically? No. The 2W. The 2W is being added on the end, right? So I can subtract 2W. That's technically my loose piece over to the other side. So that becomes P minus 2W is equal to 2L. Is our L by itself? Nope. What's still attached to it? A 2, and how is it being attached? Right now it's being multiplied, so how am I going to undo that? We're going to divide. Good. So L, I almost made it a T. Almost. L equals P minus 2W over 2. Or, if you want to make it 2 different pieces, we can say P over 2 minus W. Because the other piece, 2W over 2, those 2's could cancel out each other. I don't care which way you write it. Take your pick. You can leave the whole thing over 2, or you can make it 2 different fractions. Just be careful. This time when I had my 2 different pieces, one of them did simplify. 2W divided by 2 gave me a 1W. Okay. Up here, in with my Z and my Y, nothing canceled. So that's the only thing tricky about making it 2 different pieces. You can do it though. Questions? So it's everything you've been doing. We just don't have actual numbers to do it with. All right. Does this have any numbers at all? No. Rx minus Sx plus y equals z. Woo! We are solving for x. Okay. Good times. Let's see here. Well, we have 2 different x's going on, but one of those pieces is a loose piece. What's my loose piece? No, that still has an x with it. What's the only thing that doesn't have an x? My y is my loose piece. How could I move the y out of my way? We can subtract on to the other side. Good. Yep. So now I have Rx minus Sx. Are z and y the same thing? No. So it's just going to be z minus y. There are no numbers to combine together, so they're all just going to stay separated. Okay? I know, right? Who knew? Well, I did. Do Rx and Sx have a common piece? They both have an X, right? So could I rewrite this
Yes.
to look like this? Is that technically the same thing? It is technically the same thing. So what I did is I factored out an X. Their greatest common factor was an X. I moved it to the front. That's kind of like opposite of distribution. We're moving it the other way. We brought it out instead of putting it through. This one is a little on the advanced side, but you got it. Now what's attached to my X? And R minus S. How is R minus S attached to my X? Multiplication. So how am I going to get rid of it? Yes. We can divide the whole thing by R minus S. So then we have X equals this lovely thing. Yay. Okay. Okay, I will. So Z minus Y divided by R minus S equals X. Yes, sir. We sold these earlier in the year. But if you want one, I can see if I can get more made. But they're $15. Questions? No? Are we still a little confused? Is it like slowly getting there?
Yeah.
What's up?
Is that the only way to do it? Like, take the X and
Mm-hmm. Yep, because you have an R. Well, think about it. You have an R attached to an X by multiplying. You have a negative S attached to the X by multiplying, right? So you have to divide R and a negative S from both pieces.
So if it was anything and they both had X, you do that, or if it was Y.
Yep. Questions for me on that one? That one took a little bit more thinking. Okay. This one, 8C plus 6J equals 5P. So we got some numbers going on here. Solve for C. I would recommend you like circling, underlining, drawing a box, something around the piece that we're trying to solve for. And sometimes it helps to like rewrite it if you need to for space. Just some way you can like show yourself what you're trying to get by itself. All right, so looking at this C right here, what is attached to my C? There is a 6J. Good, what else?
8.
And there is an 8. How is the 6J attached to my C? We're adding it. So how are we going to move that? Subtract. Okay. How is 8 attached to my C? Multiply. How am I going to get rid of that? Divide. Good. So we know we're going to subtract. We know we're going to divide. Which one are we going to do first? Subtract. Good. Because 6J is my loose piece. Right? It's on the end. So we always move this loose piece over. So I have 8. There's my C is equal. Does this become negative 1 PJ? No. Why not? Good. They're two completely different types of terms. One has a P, one has a J. They are not like terms. Yeah, keep them separated. 5P minus 6J. They are not like terms. Oh, fitting. Today is PJ day. Look at that. Today is, yep. Today is pajama day. Tomorrow is Tropical Tuesday. So wear your Hawaiian shirts.
Are you going to work tomorrow?
My husband has a Hawaiian shirt I might pull out of his closet. It's Tropical Tuesday.
Why didn't you wear your pajamas?
I didn't know if I was allowed to. All right, last step. What is it? Divide by what?
8.
Divide by 8. So every single thing gets divided by 8. So C equals, this becomes 5P over 8. And 6 over 8 simplifies, doesn't it? To 2, nope, I lied. If we divide both things by 2, it becomes 3 over 4j. Or if you want to keep things simple, you can just keep the whole thing over 8 like this. I will tell you though, on the EOC, they're probably going to make it look like this. Okay, we will cross that bridge when we get there in May, but just learning this as an introduction, I'll take either one. Eventually, you're going to have to be able to separate them, and we'll do more practice with it. I know, we're already there for beat the test, aren't we? We have one more and then beat the test.
Yeah.
Questions?
No.
Do we still feel okay about it?
Yeah.
Kind of. Some of you don't look like you're like it's clicking. It's a true Monday today, isn't it?
We only have 4 days, so.
I know. The next 3 weeks we only have 4-day weeks.
Wait, what?
We don't have this Friday, you don't have next Monday, and then the next week we don't have Wednesday.
Why don't we have
Because it's Veterans Day.
Why don't we have Monday?
It's a teacher work day.
Oh, why don't we have Friday?
Teacher work day.
We probably have a 4-day weekend though.
We'll have 2 teacher planning days.
Yes.
That's crazy.
So you don't have to come to school, but I do.
That's dope.
What? I can't hear. Friday was always there. They added on Monday. Yep.
Do you have to be at school like 8 hours?
Yes, of course I will be here all day. All right. Now we're solving for C again, different equation. Again, because I am a very visual person, I'm going to rewrite this. And I'm going to draw a box around the piece that I am trying to get by itself. Okay. We will do our midterm, technically it's in January, is when your second 9 weeks is over, because we started late. So technically your second 9 weeks will be after we come back from winter break. All right, what is attached to our C right now?
A X.
There's an X. What else, Jehovah? Put it away. Just put it away. Put it in your bag, please.
I was so busy.
There's an X attached to my C. What else is attached to my C? There is a 2, and there's one more thing. A -1. Yes, there is an X. There's the minus out front shows us -1, and there's a 2. So there's 3 things technically attached to my C right now. We got to get rid of all of them. Okay. Which one are we going to move first?
Multiply.
We're going to multiply the whole thing by 2. Good.
So smart.
Good. Very careful. On the quiz this last week, y'all tried to distribute the 2 over here with this fraction. When you multiply by the denominator, it just goes away. You don't apply it to anything else. Okay? So what's left is just your numerator. Okay? My other side, though, we do multiply. D times 2, I'm going to call that 2D.
I have a question.
Yes.
Why don't we put C in the box?
Because that's what I do for me, because that's what it tells me to solve for. So I know, because it could have asked for X. Right? So I'm just making sure I know what letter I'm trying to get by itself. It usually does. Now they're being sneaky. All right. Now what? Subtract the X. You all go with that? But right now it is a positive X. So let's go ahead, because X minus X means 0X. I have negative C equals 2D minus X. Again, they're all different terms. They are unlike terms. So we keep them all separated. Last but not least, we could do either one. You could multiply or you could divide by -1. Technically, they are the same thing. I like to divide. Okay. If this was an inequality, what would have just happened? You would have flipped the sign. Good. Flashback Monday. So now my C is by itself. Woohoo! To divide by -1 means to change all of their signs. So this becomes negative 2D plus X. Okay? So just like my sign flipped, my inequality sign would flip here. Since it's not an equality, it's an equation, my pieces change their sign. So 2D is now negative 2D. minus x is now plus x. So looks like dividing by a negative always changes a sign of something, depending on what we have. How you feel? Tired? I know, me too. I've had a headache all day. Ready to beat the test? Beat the test. That's the boot through the glass from the video. Okay, let's do it. And then we got some practice worksheet we'll do together, and then we'll break. All right, Isaiah planted a seedling in his garden and recorded its height every week. The equation shown can be used to estimate the height, which is h, of the seedling after W weeks. Since he planted the seedling. Solve the formula for W, which is the number of weeks since he has planted the seedling. All right, so I'm going to rewrite this, drawing a box around what we want by itself, which is the W this time. All right. Now, I have two different pieces being divided by 4. So couldn't I put the whole thing over 4?
Yeah.
I can do the whole. Since each fraction had the same denominator, I could make it just one fraction together. There is a 3 attached, there is a 9, there is a 4, right? Which one are we going to move first? How are we going to move the 4?
Multiply by 4.
We're going to multiply. That's going to give us 4h equals 3 times w plus 9. Now what, Jacob? Jacob, wake up. I know, it's a Monday. Come on, we're almost done. Head up. What can we do now? Minus the 9. Good. How come I can't actually do 4 minus 9? Very good vocabulary. Yes, different variables. And now, divide each and every piece by 3. So we could leave it like this, or we could simplify it, which is what I'm going to do. 4 over 3, does that simplify? No. Does negative 9 over 3 simplify? To what? To minus 3, right? So again, technically, these are the same thing. This one is simplified. I think the next one's a word problem, right? Where we have to make the equation and then solve it. Okay. Questions for me? Last little bit. We can do it. Oh, excuse me. All right, here we go. Under the Brannock device method, shoe size and foot length for women are related by the formula S equals 3F minus 21, where S represents the shoe size and F represents the length of the foot in inches. Solve the formula for F. Oh, it gave me the formula. Okay, so we don't have to write it. It tells me S equals 3. They want me to solve for F minus 21. Do this. I'm going to pause. You're going to do it. You do it. You get F by itself. Go. Okay. So, a lot of you had that plus 21. But here's a mistake I saw. People made it like this. Is 21S the same thing as 21 plus S? No, that's not the same thing. So what should be here? There should be an actual plus sign in between them. Okay? If you write things together like that, that shows multiplication. Okay? Now what are we going to do?
You're going to divide it.
Divide every piece by 3. Okay? If you have F equals 21 plus S over 3. Is S plus 21 the same thing? If you have S plus 21? Yes, that's okay. 2 plus 3 is 3 plus 2, right? So if you have S plus 21, you're fine. So this is good. And then when I saw this on your paper, I asked you to try to simplify it. Okay? Because to simplify, if you divided both pieces by 3, 21 divided by 3 is 7. S divided by 3 is just going to stay S divided by 3. So this is the simplified version, which I'm trying to kind of lean you towards doing that more often.
On the test, if you don't simplify, we get wrong.
It would depend on what the directions say. If the directions tell you to simplify, then you got to do it. If the directions don't say it, then you would not be wrong. That's kind of what I'm leaning towards, is maybe an extra credit thing. Yeah.
So that's super easy.
Hmm?
Can we do it in the simplified version?
Okay. So we are done with notes, but we're going to move on to our actual practice worksheet now. Okay? I would use your notes, so I wouldn't put your notes too far away because you're going to use them to help you with your worksheets. Let me pull this back up. Come on.